The main aim of this video is for the calculation of the endpoint of 2026 Waec Chemistry Practical. I'm going to calculate this endpoint from the given variables. In the instruction, A, which is the acid, will be prepared by the teacher with 5.60 cm cube of the concentrated sulfuric acid. That is the stock sulfuric acid that is not diluted yet. The teacher is meant to measure 5.60 cm cube of that solution. And the sulfuric acid has a specific gravity or relative density of 1.84 and purity of 98%. And the base B will be prepared with 4 grams of sodium hydroxide per dm cube. Now, the endpoint is the specific volume of the acid that will neutralize the pipette volume of the base you are using in your school. I'm going to assume that you people are using the pipette with the volume of 25 cm cube. If you are using pipette volume of 20 cm cube, what you have to do is to follow through this lecture and substitute 20 for 25. You will get your unique endpoint. Now let's get into the calculation of endpoint. We are going to start with the relative density of the acid. This relative density of the acid, it means 1.84 grams per cm cube. It means there are 1.84 grams of sulfuric acid inside 1 cm cube of solution. Now, the idea of calculating endpoint is so that we will get how many grams of the acid. From the grams, we get how many moles per dm cube, which is a concentration. And from this concentration, we combine with the concentration of the base in order to find the endpoint or the average volume of the acid used. Now, let's go. This simply means 1.84 grams is contained in 1 cm cube. Now, we are interested in the mass of the pure sulfuric acid. Therefore, you go for the purity. The purity of the acid is 98%. What that means is that out of this number of grams in 1 cm cube, 98% of it is the mass of the pure acid. So how you would do it is that mass of pure sulfuric acid equals 98%, that is 98 over 100, times the mass inside 1 cm cube, that is 1.84 over 1. You are going to get 1.8032 grams of sulfuric acid per cm cube. So in 1 cm cube, there are 1.8032 grams of the pure sulfuric acid. Now, we have found out how many grams of pure sulfuric acid in 1 cm cube. Because we are working towards calculating the concentration in mole per dm cube, we are going to convert this gram per cm cube to mole per cm cube. To do that, you know the formula for number of moles. Number of moles equals mass over molar mass, right? The molar mass of sulfuric acid, you calculate it. The mass here is 1.8032 over molar mass of sulfuric acid. The molar mass of sulfuric acid is the formula mass H2SO4. Atomic mass of hydrogen times 2 plus atomic mass of sulfur plus atomic mass of oxygen times 4. If you calculate this, you have gotten the molar mass, and the value is 98. So you write 98 here. Note, this 98 is not the same as this 98. This 98 is a purity, the percentage purity of the acid. Why this 98 is the molecular mass of the acid, and we want to find out how many moles of this acid inside 1 cm cube. Now, if you divide these numbers, you are going to get 0.0184 mole per cm cube. So, this is a kind of concentration, but not actually the concentration, because the unit of concentration is mole per dm cube. and not mole per cm cube. dm cube is 1000 cm cube. So we are going to calculate the concentration of this acid inside that stock bottle by converting mole per cm cube to mole per dm cube. Now, it is agreed that 0.0184 mole is inside 1 cm cube. We want to find out how many moles in 1000 cm cube, which is the same as 1 dm cube. So you state this: 1 cm cube contains 0.0184 mole. Therefore, 1000 cm cube would contain this 0.0184 over 1 times 1000. Now, 1000 times this, you shift the point 3 times, 1, 2, 3. You are going to get 18.4 moles. Therefore, concentration of the stock acid is 18.4 moles per dm cube. Now, the teacher is instructed to dissolve 5.60 cm cube of this solution with 18.4 mole per dm cube concentration inside 1 dm cube, that is 1000 cm cube of solution. You have to apply what is called dilution principle, which states that the number of moles of stock is the same as number of moles of diluted solution, and number of mole is CV. So concentration of stock times volume of stock equals concentration of diluted solution times volume of diluted solution. Concentration of stock in this case is 18.4. Volume of stock is that volume the teacher takes from the stock to dilute, that is 5.60, equals concentration of the diluted solution, which we don't know yet, times volume of diluted solution, which is 1000, because the teacher is diluting inside 1000 capacity volumetric flask. Now you make CD the subject of the formula. CD, that is concentration of the dilute solution, equals the whole of this divided by 1000. You are going to get 0.10304. Concentration is in mole per dm cube. This is now the concentration of the acid that you'll be working with. We have to calculate the concentration of the base using the mass measured out by the teacher. And note that this concentration of dilute solution is now the concentration of the acid. Now, concentration of base in mole per dm cube equals mass concentration of the base over molar mass of the base. Mass concentration of the base is 4 grams. Molar mass of the base is formula mass of sodium hydroxide. You know that sodium is 23, oxygen 16, hydrogen 1. If you add everything, you are going to get 40. So concentration of the base is 0.1 mole per dm cube. Having gotten these two concentrations now, we are now ready to calculate the end point, that is the volume of acid required to neutralize your 25 cm cube pipette volume of the base. You have to note the equation of neutralization. This is the balanced equation, and the number of moles of base is 2, that of acid is 1. So you use this equation, CA VA over CB VB equals NA over NB. Now CA is 0.10304. You write it down, times volume of acid, that is the endpoint we are looking for, VA, over concentration of base, which is 0.1, times volume of base, that is your pipette volume in your school, 25 cm cube. If your pipette volume in your school is 20 cm cube, you write 20 here, but I'm using 25, equals number of moles of acid is 1, number of moles of base is 2, so we have 1 over 2. When you cross multiply here, 2 times this number is 0.20608 times VA equals 0.1 times 25 times 1 is 2.5. If you divide both sides by this number, you will find out that the volume of acid used is 2.5 divided by 0.20608, and you are going to get 12.13 cm cube. This is the end point of the acid used in the Waec 2026 titration. So take your screenshots, and if you found this video useful, click on like, comment, share the video, tag your friends, follow and subscribe to my YouTube channel.